Okay, so in 4.3, we're going to start something called vectors. All right, we're going to go through some terms here to start, and then I start to work through some things. This is going to require a little bit of law of sines, law of cosines to figure some things out, or some of the sections we just did. All right, so it says in this section you will study two-dimensional vectors, vector operations, unit vectors, directional angles, and applications of vectors. So the first thing here is a vector. Yikes. A vector, okay, a vector is a directed line segment, okay? It says velocity is a vector. So the magnitude of a vector, is the length of the line segment, okay? And a two-dimensional vector, right, is made up like an ordered pair, if you remember that. So we'll go through that here to set it up. Okay, of real numbers. We write these in component form with the endpoints looking like this. Okay, so if the endpoint's at AB, you notice this does have a little bit of a a point to it. Okay, so it's not a parenthesis. That's how we're going to write that, right? So this is something called component form. Component form. Now, from there, with the endpoint there, so the linear combination, linear combination of a vector looks like this. So there's an I and a j component to it, okay? And it's basically your x and your y, all right? Where a and b are respectively the horizontal and vertical components of a vector. When a vector is drawn in standard position, the arrow begins at the origin, so that's good to know, all right, and it goes to this point, AB, and then the vector is drawn in component form here, okay, or like that one with the points there, right? So the next thing says a direction angle, so here, a direction angle is the angle the vector makes with the positive x-axis. All right. Now, the next thing it says a zero vector, which is kind of interesting, comes up every now and then, has zero length and no direction. When you add two vectors, then you are finding something called the resultant. So a lot of terms here we're going to come back to. The resultant of a vector. A vector with length of 1, okay, is called a unit vector. And a scalar is a number which has only magnitude and no direction. Okay, now, just a little bit of physics background here, right? If you had physics, the difference between speed and velocity, right? Velocity is a vector, because if you remember, velocity has magnitude and direction, all right? That's also in Despicable Me, but speed is just speed, right? So if I say I drive home to Gettysburg going 55 miles an hour because I'm going west, I don't say in normal conversation, I just give you my speed. I don't say I'm going negative 55 miles an hour. You'd be like, what? Okay, so that's kind of where this goes. And then there's other physics components to this is basically where it comes from. All right, so let's get to apply some of these. All right, so first of all here, with the standard position vector, the initial point is at the origin, and it terminates at AB, okay? So, and we can have scalar or multiples or however you want to do it. So let's say I wanted to draw the vector, right, that's going to have this piece here, okay, which could also look like this, just to try to apply some of these things. Now, what would this mean? What this would mean, right, is that if I was drawing this in standard position, I would start at the origin. 4, 3 would be my point. So 1, 2, 3, 4, 1, 2, 3. Yeah, this right here would be the vector. So it starts at the origin and terminates there. Sort of, we're going to talk about a tail to head and head to tail type situation, okay? Now, the component vectors, if you want, okay, would be there's a vector here, okay, that we're going to call J. And there's a little j, should be. Let me fix that. I guess that looks like a big J. So little j, and then there would be another vector here, and we're going to find out through making a rectangle out of that eventually, okay, is that the component, the two things there that go together to make the vector, those are the components. So, and just a reminder here that I represents the horizontal component, and again, this factors into physics if you've had it, horizontal component. All right, and little j is the vertical component. All right, and that would be written then in standard form. Okay? All right. Now, let's see if we can come up with this one then. All right, so the magnitude or the norm of the vector is the length of the segment. Okay? Now, I'm used to seeing this with two lines. I think that's how we're going to do it here. All right, so it's going to look like this. If I want the magnitude of v, that's going to be the symbol for it. Okay, and we're going to try to figure that out. Now, if we look at this then real quick, all right, hopefully this looks familiar here. Okay, I don't know if it does. That's basically the distance formula. Okay, it's also kind of Pythagorean theorem, which are both the same thing. All right, so I'm going to take my change in x squared and take my change in y squared, and that's going to give me the magnitude. All right, it says, so also, if they give you this, okay, just in that form, right, AB, hopefully we know that A is the horizontal component and B is the vertical component. That makes this, again, the same thing here with the magnitude of that. All right, so it's basically just that formula. Now, if we did this then, all right, just to be, I guess, kind of odd about it, right, is if I gave you the point 3, 4, okay, actually, you know what, let me go 4, 3, just like up top here. I don't know why that's, okay, let me go back to this. So if I go back to my vector that I did up here, 4, 3, right, or, right, 4i plus 3, or, yeah, plus 3j, all right, let's try to figure out the magnitude here. So here would be the idea again, right? This would head out here to be 4 this way and 3 this way. So not super duper. But again, those would be my two components. This would be my point. So if I wanted to find the magnitude of that, what could I do? I'm hoping it's pretty basic to see that this does apply to the Pythagorean theorem because it's in standard position, and I would get this right here. A lot of times we complete the rectangle like so, all right, where this would be 4 and this would be 3, right? So again, in the component that we would have, what would the magnitude be then, right? The magnitude of v, if you know your Pythagorean theorem triple, and that's what it is, but what would we do here? If I had to subtract, I would, but in this case I don't. It would just be 4 squared plus 3 squared. I'm not sure if you're aware of the triple, that's kind of why I picked it, but if you do that in your calculator, that's going to tell me that the magnitude of this vector is 5. Okay, so given a horizontal and vertical component, the magnitude is actually the vector itself that cuts across there. Okay, all right, let's try one more here for this. Sketch and find the magnitude of this. Now, when I have negative 2i plus 3j, let me just say that to write this in vector form, right, I draw my little thing like this, I would get negative 2, 3 is my vector. Okay, so for this one then, how would I sketch this? So I'd come here, this would be part of the component here. Okay, negative 2 does have direction, so this would be part of it coming this way. This way. All right, and then the 3j, positive 3j, would come up this way. This would be my point, the resultant, if you will. Okay, the vector itself would be there. And a lot of times then we sketch the rectangle like that. So that's what it would look like. Now, what is the magnitude of the vector then? Okay, the magnitude of the vector would be equal to basically just Pythagorean theorem, right? So negative 2 squared plus 3 squared, that's going to give you the square root of 13. Okay, now we're going to leave the square root of 13 for now. It's kind of a math answer, right? If they actually wanted that to be a practical answer, we could make it a decimal. That's pretty much it. That we can find the magnitude of a vector that's anchored here at the origin from two component vectors or from vector form. All right, let's do example 2. All right, so this says, given P and Q, sketch PQ, translate the position to a position vector, write in component form, and write as a linear combination. So let's see if we can put this together. So from point P, so 1, 2, 3, 4, up 1. Okay, we have that one. And Q is at 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. I got that right? Oh, great. Somewhere up here. So what I have here is this goes from P to Q. I kind of missed there. P to Q. Okay? So that's what I have there. So I sketch PQ. All right? It says translate to a position vector. So I'm going to basically pick this thing up. Not really. But I'm going to move it over here so that it is as a position vector, I'm going to anchor right there so that this becomes my new P, if you want. Okay? So for that one there, right, I'm going to make it to 0, 0. Let's try to see if I can translate it over to do it. So if I go down 1, right 4 for that one, I got to come down 1, right, and then right 4, 1, 2, 3, 4. Okay? If I did that right. So 5, wait a second. So I go down 1, left 4, which means if I go down 1, and then right 4, this should take me to the point 3, 4. Yeah, right. Sorry. I don't know why I was in trouble there for a second. So basically, I just picked that thing up and moved it there. So if I do it that way, this becomes the point 3, 4. Okay, so all I did was pick this one up and move it over there. Okay, now, with that being the case then, what is the position vector? Okay, you can do it a couple different ways, right? I could do my subtraction. So one way to come up with it is I could subtract my x's to start. So I could take 7 minus 4 is how they do it. And then I could take the other one and take 5 minus 1, sort of y2 minus y1. The other thing is I can look at my picture and tell that I ended up at 3, 4. Okay, without a picture, I guess that's what you would do. How could I write this in component form? Okay, again, this becomes 3i plus 4j, if I'm writing that way. And then, I don't know, maybe we'll go through and find the magnitude here. They didn't ask us to do that. But here's the deal that I need you to understand, okay? If you put this together, is that if this is angle z, if this is vector z, we'll call it, okay? Just one thing that I need you to know is that vector v, okay, which was the original, and vector z, these are equal vectors, okay? So I want you to know that this vector here is equal to this vector here. I just moved it. Okay, that's the nice thing about vectors. They can be moved with different things. And the anchor points here matters for the starting point, okay? Let's go ahead and find the magnitude even though it didn't ask it. How would you do it? I think it's pretty simple, right? It could come down like this. I think we already know it. How would you find it? Once it's in component form or however you want to look at it, it would be 3 squared plus 4 squared. This would make the magnitude of this vector equal to 5. Okay? All right, so those are the first 2 pages. We're going to stop it there. All right, and we're